It's onward and upward. We're heading to Chapter 8 now with our Excel tutorials. Chapter 8 is kind of a tricky chapter to get your mind around, so I'm hoping that these tutorials will really help. All right, let's read the problem. We're doing 8.1, number 21. It says, the length of human pregnancies is approximately normally distributed with mean mu equals 266 and standard deviation sigma equals 16. All right, so the first thing they want to know is what's the probability that a randomly selected pregnancy lasts less than 260 days? Now notice it says that it's normally distributed, which means in order to find the probability that x is less than 260, we're going to need the probability function for the normal distribution, which is norm dist, not norm s dist. Norm s dist is dealing with standard z-scores, but this is norm dist. 260, the mean was 266, standard deviation 16, true. There we go. Enter. There's your answer. Part A is done. This is actually, I don't know if you caught it, but Part A is a review question. This is what we did in Section 7.3. All right, now on to Part B. We need to know the shape, we need to know the center, and we need to know spread. Shape. Now the shape, I happen to know, is normal. Now how do I know it's normal? The reason I know it's normal, there's two valid reasons you can say. Let me put it right here. One reason you can say is because n is greater than 30. Well, we don't have that in this problem. N is not greater than 30. 30 is just a rule of thumb that they give in the central limit theorem in this text. So we don't have that. That must mean we have the other option, which is that it's normal to begin with. Look, right here. It's normally distributed from the start. It was normally distributed for just one pregnancy. That's how we were able to find this probability for a single pregnancy in Part A. If it wasn't normally distributed, we wouldn't have been able to do anything so far. So it's normal because the problem states, that the data is normal for n equals 1, right? They give that to you in the instructions. All right, there we go, normal. Let me add in a row here just to kind of keep it clear. The center is the mean, so let me insert a symbol here. It's mu, close, I introduced two of them, for x bar. That's the center. I can't really do the symbol in here. I'd have to go do it someplace else. But now what is the center of the mu of the x bars? What does that mean? Okay, if you take a group of 20 pregnancies, random pregnancies, they're going to have a sample mean, right? X bar, right? How long they last on average. Then you go to your next group of 20 pregnancies and they have an X bar. And your next group of 20 pregnancies and they have an X bar, and so on. And then what you do is you add up the X bars from all the different groups of 20 pregnancies and divide by how many there were, and you have the mean of those. But if 266 was the mean for the population, shouldn't every one of those samples be kind of around 266? Yes, they should. So the mean of X bars is actually the same as it was in the first place, right? That's your center, right? The center is 266 still, no change. Now what really gets dicey is the spread. Spread is, let me insert the symbol here, the sigma for the X bars. It is no longer called the standard deviation. It's going to be called it's going to be called the standard error. Standard error is how far apart the groups of size 20 are from each other. The formula for that is sigma, let me type it, sigma, close, divided by the square root of n, your sample size. So in our case, that would be 16 divided by the square root of 20. That, right there, that's your spread. It's called the standard error, not the standard deviation anymore. But there it is. Notice how much smaller it is, right? Because groups of size 20 balance each other out. They're not going to be as spread out as individuals are. Individuals can be give or take 16 days. But groups of size 20, they can only be apart from each other, their averages can only be about 3.577 days apart from each other. It's just hard to get groups to be far apart, way harder than it is for individuals. All right, now we've done the part A and B. Next we'll head to the probabilities questions for C and D.